Hello.
Look, excellent. That was Edwin. See? And 30 years down the road, I'm using this video still. You'll be there, man. Right? You're famous. Okay. So we're going to go over in this video some questions from the Delta Math link that's asking you to kind of use your understanding of the mean value theorem. So I'm actually going to start, as I said, on the third one. All right. Now, a couple of things that it's saying in the problem to start. We have a function f, all right, and it says it's continuous on the closed interval -1 to 2 and differentiable on the open interval -1 to 2. That's kind of the first things you need to see if you're going to use the mean value theorem. Okay, what I told you guys yesterday is that if those are true, then the slope of the secant line, right, that connects the endpoints, the slope of that secant line, there should be some x value in that interval that when you find the slope of the tangent line at that point, it'll have the same slope. Right? I tried to show you yesterday in that problem where the lines were parallel. You guys remember that from yesterday? Okay, so we're going to kind of use all that, all right, to help us answer this question. So it wants us to determine the validity of the following statement. There exists a value c in this interval such that f prime of c equals 1. So the way I want you to go about doing this is first focus on the two endpoints. So what are my endpoints here? What are my 2 points that are the endpoints here? -1, -8, and 2, -8. Okay? So let's go ahead and find the slope of that secant line. All right? So the slope of this line is going to be -8 minus -8 over 2 minus -1. What is the slope of this secant line? It's 0, right? 0 over 3, which is 0. All right? So we're saying in the mean value theorem, right, that there's some value x, which we call c, that when I find the tangent line at that value, the slope should also be 0. Now take a look at what this says. This says 1. So far, have I found one that matched? No. So what I'm going to do is I'm going to take the other points. So start with -1, -8. And what's the point that I haven't used yet? 1, -6. So I'm going to find a secant line for a slope for these 2 points and see what that slope is. So do it again. All right, so what's -6 minus -8? +2. What's 1 minus -1? +2. 2 divided by 2 is 1. Now, what you should notice is that what I just found matches this slope here. Okay? So what we're saying is, according to the mean value theorem, there is some x value, which we've called c, between -1 and +1, that when I take the tangent line at that value, the slope is going to be also 1. All right? So when I said determine the validity of this statement, this is going to be a true statement. All right? There is some value between -1 and 2, because we said it's between -1 and 1, so it has to be between -1 and 2 as well, that is going to have f prime of c is equal to 1. So there's going to be options that'll say this statement is true, this statement is false, this statement is true or false. This one you're choosing true. Okay? Any questions on number 3 so far? Now we're going to back up, right? So just to the last one, back up to number 2. Yes, Kyle, go ahead. Guess what's happening in number 2? Your brain already knows. I love it. I try my best on these because there's so many different ways they're going to ask you questions that show you all the different iterations, but it may not be perfect. So if you're having questions when you're practicing after we get done here, I can walk right on help. Okay? All right. So same thing, like almost identical. It tells me it's continuous, tells me it's differentiable, all right? And the same kind of statement. We're saying that there's some value c that when you take the derivative and evaluate it at c, you should get -15/2. So if we're going to use the mean value theorem, I always tell students to start with the endpoints. So that'd be 1, -9, and 4, negative 28. Let's find that slope. Okay, what's negative 28 minus a negative 9? And then what's 4 minus 1? 3. And I don't actually know what that is as a decimal, but if you wanted to, we could get it. Does anyone know what it is as a decimal? You don't have a calculator or a phone, so it makes it tough. It's going to be negative 6 point something, yeah. Is it repeating?
Yeah, it's repeating.
Yes, you're right. Negative 6.3 repeating. So I'll put it to the side here. I guess I don't need to put that if I'm going to put the repeating. Okay. Now, so Gael's, your brain was already thinking, what happens if it doesn't match? First off, negative 15 halves. What is negative 15 halves as a decimal? Awesome. So did that match? No. So far, I'm not able to make a decision about true or false or either true or false because so far it didn't match. So let's do the next two. The next two, I'm going to stick with my first point, and now I'm going to use that middle point. Okay, yes? Do you have a question? No? Okay. Negative 14 minus a negative 9. Negative 5 over, what's 2 minus 1? 1. So this is negative 5. Now, when we did this in number 3, at this step, it matched, right? At this step, it matched. Alan, give me your phone. You can get it from the assistant principal at the end of the day. Does it match?
No.
Does it match? It doesn't match. All right, so I got to do another one because there's another pair that I haven't done yet. The middle point, so 2, negative 14. And 4, negative 28. It does not. As long as you're doing, there's 3 of them, right? Because you've got 3 points. So there's 3 potential secant lines here. Okay, what's negative 28 minus a negative 14? Negative 14. Over, what's 4 minus 2? 2. Negative 7. Oh, we got close, but is that negative 7.5? No. So, based on this, all right, you should notice what is our largest or highest slope out of these 3? Out of these 3, what is our largest or highest slope? Negative 5. I know it's weird to say that. Right, but negative 5 is actually our biggest or largest slope, right? What is our smallest slope? Negative 7, all right? So when I look at negative 5 to negative 7, what do you notice about negative 7.5 compared to negative 5 to negative 7? Is it in between those two? No. If this is not in between these two, then we don't know if this is going to be a true statement. It could be, because there's other points that I just don't know. Right? So I'm not going to say false. I'm not going to say true. I'm going to say it could be either true or false. Because I don't know. Right now, it's like one of those questions where it says, like, you don't have enough information to answer. That's what's happening here. So you're going to choose the one that says either true or false. That's one of your options. Okay? So that's kind of, so Gael, hopefully that helped your brain answer your question of what happens when it doesn't match, all right? And in this instance, you have to look at the range of slopes. I told you guys the highest one was negative 5, the lowest one was negative 7. What if this were in the range? What if this was between negative 5 and 7? Then it would be true. Okay? But since it's not in the range, you cannot say it's true or false. Okay? Everybody good? All right. Back up. One more. Number 1. This is the last one. Now, this one I chose to do last, even though I put it first. This is, I think, is the trickiest one. So I'm going to do my best to try to explain it for your brain. All right. You're going to see that the work seems similar, but the way they're asking the question is different. Okay. The first two that we did, number 2 and number 3, told us the function is continuous and differentiable over some interval. In this one, it's saying it's differentiable. And the question or the statement that we're going to be thinking about in terms of our answer says the function is continuous on this interval. All right, so it's a little bit different. We're going to determine, do we think this is true, false, or either true or false. Okay, so what I'm going to do is I'm going to start with my endpoints. So -2, -9, and 2, -21. Let's find that slope. That's it. Okay, -21 minus a -9. So that's really -21 plus 9.
30.
So -21 plus 9 is -12. And then 2 minus -2 is going to be 4. So this is -3. The first one we did. So this is the endpoints. What's the slope of the secant line? -3. Okay? Now, according to the mean value theorem, if your function is continuous and differentiable, then there's some value c that when you evaluate it at that derivative, right, should match your slope of your secant line. So what do you notice about those numbers? They match. But look what the statement says in the paragraph. It says there does not exist a value c in this interval such that f prime of c equals -3. So they're telling us that there's no value where this is true. Okay? So if that's the case, if there's no x value where this happens, then this statement here must be false. There must be some discontinuity happening in this interval, because if this was true, then would there be a value that makes this true? Yes, there would, but they're telling us in the paragraph that it's not true. There's no value c that when I take the tangent line at that x value, I get the same slope as my secant line. So because they said there does not exist this value, then I know this statement here must be false. There must be some discontinuity happening in this interval. So I'm going to put... Well, in this case, I was able to find the slope matched on my first finding of a slope of the secant line. Well, what if this would have been -2? Then what would I have done if that was -2? I would have continued to using the first and the second point. If that's on -3, then I do the second and third one. Okay, and go from there. All right, but in this case, I think the hard part of this is they trying to change the way in this they're asking the question. Okay, yes, man. Ooh, good question. Let's see if you can figure that out. Don't worry, I'll be here. I'll help you out.